In chapter 4, column number 55, says the gross domestic product, GDP, is the total value of goods produced and services provided in the country during 1 year. Below is a table showing the United States GDP in millions of dollars for every other year from 1929 to 2017. So here's the data set. We'd like to use technology to create a scatter plot for the data. And then we're going to use technology to do certain things with it. So we're going to go ahead and use Desmos for this and see how things go with it. Sorry, give me a second. Okay, so the nice thing about Desmos is you can actually just copy the data set from a Word file. And then over in Desmos, just paste it right in. Notice when I pasted it in, it automatically plotted it up. And Desmos automatically set the window based on the data that you have. When I look at this data set, it looks like it's coming along and it looks like it starts to go up really, really fast. So this looks like an exponential growth model. So we're going to actually model this one with exponential growth. If you would like to copy the graph, you can actually do share the graph and then export the image if you need to copy it into your homework. And we're going to use technology to create this scatter plot for the data. We use technology. We're now going to use technology to create an appropriate model. Again, it looks like what we call an exponential growth model. So I'm going to go back to the models in the start of the modeling section in the book to see what the different models are. An exponential model looks like y is equal to a times b to the x. So that's what the model actually looks like. So we're going to go ahead and do that. We're going to go ahead and type that into here. My input value is y, and in this case, it's y sub 1. So the way you do this in Desmos, you just type a y and then a 1, and it automatically makes it in a subscript. In Desmos, to model, you just put in the tilde to make it say that you want to model. Then you type in the general form of the equation. In this case, an exponential is a times b to the, and the to the is the caret, which is above the 6. So shift number 6 and then x. But if you just put x, it won't know what x you want. You want to do x1. Again, you just type a 1 and it makes a subscript. Notice it automatically plotted it, and created the model, and then it plotted it with the data. And it looks like it models pretty good with the data. The parameters, the a and the b are our parameters, and it now gives me those values. So I can now write out what my equation is. So if you want to type up what your equation is, you can now just say that y is equal to a, which is 6.8 times 10 to the negative 37, a pretty small number, times 1.05 to the x power. So there's your equation. Again, the caret means to the. Next, I want to determine the r-squared value for the model and interpret it. So the r-squared value is actually given right here. Desmos says that the r-squared value is 0.985, which means 98.5% of the variability in the y variable, which in this case is the GDP, is explained by the model. So that's actually pretty good. That's a lot of the variability. In other words, knowing how much y changes depends on what year you happen to be in. All right, and then we want to use this model to estimate what the US GDP is in 1990. So you can either type this into your calculator, you can type it into Desmos. I'm going to copy and paste. I can copy this directly into Desmos. The only thing is that Desmos needs to kind of have a little bit of work done with it. First off, it doesn't have an X. It needs a multiplication symbol. It doesn't like having that 37 where it is, so we're going to actually get rid of that 37. And then you can kind of see how it fits with the data. And I drew that. It's a little bit farther off just because of rounding errors. Things aren't as perfect as they were. And I actually want to put my X value in. So my X value is actually 1990. I can type in 1990 and it gives me what that value was. So it tells me that that value is 900 and, well, let's get how many decimal places we have here. So let's get rid of some of the decimal places because we don't really need all those. Put a couple commas in here. So 998,191 millions of dollars, because remember the GDP is in millions of dollars. I want to know if we can trust this value. Well, one of the things I noticed is 1990 may not be one of the data values here. This is why we use the model, because 1990 is not actually one of the data values, but it could be one of the data values because it's a 1989 and then a 1991. So 1990 could be a value we could have measured. It could have actually been existing. It is in the original data. And notice that this value is not too far off from what these values are. So it could definitely be trusted because it's part of the original data. Now we want to use this model to predict the GDP in 2050. So we're going to just change our 1990 to 2050. And when I do that, I get this number here. Again, we'll see exactly what that number is. We don't need all those decimal places. I want to make that a 3. Put in a few commas to help you see the number a little bit better. And it's 18,645,413 millions of dollars. Now, this one is really not part of our data set. Notice we go up as 2017, 2050 hasn't even happened yet. We're not even anywhere there that year. So we probably can't be sure that this value will be the correct value. So we probably shouldn't trust this value for the future because we don't know for sure that this model will keep being the model that's making the data.